So hi everyone, I'm Vineet Sharma and I'm excited to showcase my project, a Gen AI-powered chat that is built using Llama 3 and Streamlit. This chatbot runs completely offline on my system and giving you privacy, speed, and full control over data as well. Means your data will be kept private completely. Now let's talk about its key features. This chatbot is built on a locally downloaded large language model that is Llama 3, as I said earlier, using Ollama. Since it runs locally, it has many benefits like your data stays private, nothing is sent to cloud servers. Secondly, it is fast, reliable, and works without an internet connection. So, the UI is powered by Streamlit with a clean and stylish dark theme, animated chat bubbles, and a smart assistant that I'm going to show you later. It also remembers the recent messages. You can even download the full chat history at any time and clear it as well. Now let's move to its demo. So guys, let's take a quick demo. The first question I gave him is, "Hi, how are you?" He replied. Now the second question I gave is, "Give me a Python code for a palindrome check." And here's the output that it has given me. Now the third question we can gonna take is, which is so here's the answer. The largest country in the world by land area is Russia, which covers approximately 7.1 million square kilometers. So as we can see that here we have two options for clearing the whole chat. After clicking on this button, we can clear the whole chat. And the second one is download chat. We can save all the history, all the chats we have done till now. See them. So that all the chat we had recently has been cleared, and we can download the chat here as well. So this was the. So now move to some most important files of this project. The first one is app.py. This is the main file which powers the entire chatbot. At the top, I import Streamlit, LangChain Ollama, wrapper, and time. Then I define a large CSS block as you can see here using st.markdown to style the interface of my app. This includes a dark 3D background, chat bubbles, and a custom animated typing effect to simulate a realistic chatbot conversation. Now, here's the most important part. Let me show you. Yeah, this one. This line loads the locally installed Llama 3 model via Ollama, allowing it to respond to prompts fully offline. The messages are stored using st.session_state. Just a minute. Yeah, this one. So the chat remembers the last few interactions. I also provide a clear chat button, as you can see here, and a download option to save the full conversation. Each user or assistant message is styled using the chat bubble. Yeah, this one. Function. This is the function which is responsible for the style of the assistant message. Now the next function is generate response. This function triggers Ollama's response using the last three messages as context, making it lightweight and fast comparatively. Finally, the Streamlit chat input. Just a minute. Yeah, this one. The Streamlit chat input handles the user prompt and the assistant responds with a delay in typing animation. So this entire file combines UI, logic, and LLM response in a compact and efficient format. Now the second most important file we're going to see is this. This is a reg file, as we all know. Now let me explain the reg component of my project, also known as Retrieval-Augmented Generation. This script enables the chatbot to answer from custom documents instead of just relying on the LLM's pretend knowledge. At the top, I have imported essential modules like LangChain, FAISS, and Google Palm and Embeddings. Also, I have imported prompt template from the LangChain prompts. Then I use load.env to securely load my Google Palm API key from the .env file. Next, I initialize HuggingFace instructor embeddings, as you can see here. These embeddings help convert text into vectors, which are used to build a FAISS vector database from my own CSV dataset, which acts as the chatbot's knowledge base. That is most important here. Now the next function is create vector DB. This function loads the data, convert it to vectors, and saves the FAISS index locally. Then comes the Then comes the get QA chain function. It loads the saved database, retrieves relevant context based on the user query, and combines it with a custom prompt using LangChain's prompt template. Finally, I use uh, just a second. Yeah. Finally, I use LangChain's retrieval QA. So in this function, the role of this function is to generate the answer strictly based on the context from the CSV file. If the answer is not found, the model responds with "I don't know." This makes the chatbot factual, context-free, and accurate, and which is also great for real-world use cases like FAQ bots, customer service, and internal tools as well. So the next file is requirements.txt. This file lists all the Python packages that are needed to run the project. Like here we have written Streamlit, Google Generative AI, Python.nv, and Ollama as well. It is important for portability. And the next one is readme. Finally, the readme file, which I've also added in my GitHub repo, it gives a complete guide like how to install dependencies, how to run the app, and what features are supported. I've also added the link to this demo video in my GitHub repo. You can see over there. Now the last file is main.py. Like this was a basic stage of my project when I have not used LLaMA 3. I have just used the basic NLP, which the model works using the dataset. Like when I've written any question in the bot, it's just to retrieve the answer from the dataset I have given to him. Like it is limited, not as vast as Llama 3. It just answers to a basic limit. It is not that accurate as much as Llama 3 is. Thank you. So guys, let's conclude the project here. This setup gives you fast offline first GenAI with Llama 3 and offline cloud-based power using Google Farm. Private with the functional chatbot using CSVs. If you found this useful, feel free to check out on GitHub repo and try it yourself too. Thank you.